Yes, good morning to all of you. So today we are going to see about design of a levers. Already we have seen that quarter joint and knuckle joint. Okay, now so today's point of discussion is of levers. Okay, so one by one we will see what is meant by levers, what are the types of a levers, and how to design that lever. Okay, so the next so levers, okay. So first, what is mean by lever? Okay, a lever is a rigid rod which is capable of rotating about a fixed point, which is called as a fulcrum. Okay, you can note down the points at the time of a lecture as well. Okay, so lever is a what? It is a rigid type of a rod. Okay, and which is capable of rotating about a fixed point, and that fixed point is called as a fulcrum. Okay, so that rod, particular rod, will rotate about that fulcrum point, and that fulcrum point is a fixed one. Okay, so this is what a lever. So lever is a rigid type of a rod. Okay, so it is of lever. Okay, now the next, it is used to lift the heavy loads by the application of a less or very less efforts. Okay, so that lever is used to lift the heavy loads. Okay, by the application of less or very less effort. So by means of a very less or not that much high efforts you can apply to any particular application to lift that particular heavy load, or if you want to move the load from one place to another, you can use the levers. Okay, I will show you the example, then your whole idea will get it clear. Okay, now what is lever? It is a mechanical device which is mostly operated by hand or by foot. Okay, it is a mechanical device, not a device, it's a mechanical rod or something else. Okay, type of a lever, and it is mostly operated by, you can operate it by means of a hand or by means of a foot. Okay, then next, here is the diagram which will shows you the what lever. Okay, this golden portion, golden type of a rod is nothing but a lever. Okay, and at this center it is what a fulcrum, means it is fixed point. Okay, and here is the, at the right hand you will apply the effort, and at the left hand you can lift the load by applying the effort on another side. Okay, the best example for it is the seesaw. Okay, as you have already seen, already you have played with the seesaw in a garden. Okay, in at the time of a school, or at the when you are very when you are having in 10 to 15 sorry 5 to 10 age. Okay, that's seesaw. Okay, means what, at the left hand side your friend will sit, at the right hand side you can sit. Okay, and then you can play with that seesaw. Okay, the same like as it is, this is what the lever, and at the center it is fixed. Okay, so this is what a lever. Okay, that rod is what is called as a lever. Okay, so now the best example, another, here is right hand side you can see. Okay, that boulder or rock, that person is going to move from one place to another. Okay, so here is what the in hand he used a lever. Okay, or we can say the rod. Okay, it is a rigid rod. Okay, and here at the top side he is applying the efforts, right? And at the center there is a fulcrum, so he use one another rock to support that lever. Okay, and that fixed point is nothing but the fulcrum, and here is what boulder or that rock is of load. Okay, and he is going to move, or he is going to lift that particular load by means of applying effort at the right hand side. Okay, and here is the fixed point, and which is called as a fulcrum. Okay, so this is what a lever. All of you, are you getting this, what is lever? Yes, please. Yes, are you got what is mean by lever? Okay, so it is a rigid type of a rod. Okay, and at the one end you can apply the effort, and at the another end you can lift the load. Okay, so this is what a lever. Okay, and it is fixed at the middle point, or you can, according to the fulcrum, there may be various types of levers. Okay, so at the middle there is a fulcrum which is of a fixed point. Okay, so this is what a lever. Okay, so in some exam it may be asked what is meant by lever. Explain with a example. Okay, so should we go ahead now? Okay, so this is what a lever. Okay, so now the next part is now lever, which consists of three main parts. Okay, now what are these three main parts? We will see one by one. So the first point is what? Fulcrum. Okay, already we have seen in now first slide what is meant by fulcrum, which is a fixed point. Okay, so this is what a fulcrum. Now the second is a load arm. Now what is load arm, that we will see. Okay, and third one is a effort arm. Now what is effort arm, that we will see. Okay, so these are the three main or basic parts of a lever. Okay, fulcrum, load arm, and effort arm. Okay, so next here is the diagram. Okay, here is the construction of a lever. Okay, here is the this is what you can say, the rectangular type of a, or a circular end of type of a lever. Okay, and at the right hand side, here is a effort is applied. Now P denotes effort, okay, which is in a downward direction. Okay, and at the left side there is a F denotes load. Okay, or you can consider here as a W. Okay, but this F is nothing but the load, and which is acting in a downward direction, which is the weight of the particular load. Okay, and that downward direction F is nothing but the load, and here is the right hand side, P is nothing but the effort which you are applying. Okay, now that L1 and L2. Okay, now what is L1 and what is L2? Okay, so L1 means what? And okay, at the middle it is a fixed point, means what? It is what? The fulcrum. Okay, so at the middle it is fixed one, that is a fulcrum. At the right hand side in a downward direction, P denotes efforts, and at the left hand side the F denotes load. Okay, effort, load, and the fulcrum, these are the three main basic parts of the lever. Okay, then not a parts, these are the three forces which are acting in a downward direction. Okay, that here will be the reaction force will be there at the fulcrum. Okay, that we will see it later. Okay, so the F is the load and P is the effort. Okay, now here is the L1 and L2 is there. Okay, now what is L1? L1 means what? The perpendicular distance of the perpendicular distance from the fulcrum to the effort. Okay, that is denoted as a L1, and that L1 is called as a effort arm. Are you getting this? Okay, now what will be the L2? Okay, it is the distance, perpendicular distance from the load to the center of the fulcrum. Okay, so that is, it is called as a load arm, right? So L2 is a load arm because the distance from the that load, and this L1 is the effort because the distance from the effort which was applied at the right hand end of the lever. Okay, are you getting this? What is load arm and what is effort arm? What is F? What is P? Where is the fulcrum? Are you getting this? Yes, please. Yes. Okay. So that P denotes what? Effort. That F denotes what? Load. At the center, there is a fulcrum. Okay. L1 is what? The effort arm, and L2 is what? Load arm. Why L1 is effort arm? Because the perpendicular distance from the effort which was applied at the lever, and L2 is the load arm. Why it is load arm? Because the distance which is took from the load arm, took from the load. Okay, okay, that distance is up to the fulcrum. Okay, middle of the fulcrum. Okay, this is L1 and L2. Okay, fine. Okay, so I think up till now you are getting this. Okay, now the next is what? That F is the force. Okay, F is the force which is produced by the lever. Okay, and P is what? The effort which is required to produce that force. Okay, so the F is the force which is produced by the lever. Okay, and that P is the force which is required to produce that particular force. Okay, so the force F is often called as a load. Okay, already I have told you here is F is nothing but the load. Okay, or force you can say. Okay, and the perpendicular distance of the line of the action of any force from the fulcrum. Okay, so the perpendicular distance of the line of action of any force from the fulcrum is called as arm of the lever. Okay, this is what the arm. Okay, then L1 and L2 are the effort arm and the load arm respectively, as I have explained you right now. Okay, that L1 is the effort arm and L2 is the load arm. Okay, so taking movement of a forces about the fulcrum. Okay, I will take the movement at the fulcrum. Okay, so once you will take the movement at the fulcrum, what you will get? Here it is, right? F into L2, okay, is equal to P into L1. Now how it comes? Okay, when I will took the movement at a fulcrum, okay, that P will comes in a clockwise direction, okay, and the F will come in a anti-clockwise direction. Okay, so here P will that clockwise direction I will consider as a positive, that anti-clockwise direction I will consider as a negative. Okay, so here is what? the force into perpendicular distance. Okay, so P into L2, sorry, P into L1, okay, which is of plus, then minus F into L2. Why? Because that load is in anti-clockwise direction. Okay, so once I will rearrange the term, I will get P into L1 is equal to F into L2, because this is anti-clockwise direction, minus sign, it will goes to the, when it will goes to the right hand side, it will get positive. Okay, so P into L1 is equal to F into L2. Right, are you getting this up till this? Okay, how it comes? F into L2 is equal to P into L1, taking the moment at the fulcrum. Okay, now the next, the F upon P is equal to L1 upon L2. Okay, so I rearrange the term, I have kept keep that P in the denominator and L1 upon L2. Okay, that load upon effort is equal to L1 is the effort arm divided by load arm. Right, F upon P is equal to L1 upon L2. Are you getting this up till this? Okay. Now the ratio of load to the effort. Now ratio of load to the effort, that is F upon P, is called as what? Mechanical advantage of the lever. Okay. So the ratio of F upon P is called as mechanical advantage of the lever. Right. And the ratio of effort arm, that is ratio of effort arm to the load arm, that is L1 upon L2, is called as leverage. Okay, so this is what advantage and this is what leverage. Okay, are you getting this? What is advantage, mechanical advantage, and what is leverage? How it comes, all of you? Yes, please. Yes. Okay, fine. Okay, so I think all of you get this, how it comes. F upon P is equal to L1 upon L2. Okay, so that F upon P is called as mechanical advantage, and L1 upon L2, that is effort arm to the effort arm to the load arm, is called as a leverage. Okay, so in same exam point of view, this type of a question will be definitely asked. Explain the mechanical advantage and leverage for 4 marks. Okay, in that you have to draw the diagrams, you have to explain all the things, what are the main basic parts of the levers. Okay, then you have to explain how it comes. Okay, and then you have to show that equation F upon P is equal to L1 upon L2, and that F upon P is called as advantage, and then L1 upon L2 is called as a leverage. Okay, so it was, question was, I think last to last same, it was in same exam was asked what is mechanical advantage, but some of the students, they don't know about mechanical advantage, so they wrote the advantages of the mechanical advantages is something related to the mechanical. Okay, so it is not like that, just keep in mind, mechanical advantage means this term F upon P. Okay, but some students, the students those who don't know what is advantage, mechanical advantage, they have written the advantages of the mechanical, so don't do that. Okay, so why? Because I have gone through it, that's why I am alerting you. Okay, so the mechanical advantage is the F upon P. Okay, so L1 upon L1 upon L2 is the leverage. Okay, so I think up to this you are clear what is L1, what is L2, what is F, and what is P. Okay, so should we go ahead? Okay, now the next part, the types of a lever. Okay, so there are various types of a lever. Okay, we will see one by one. Okay, so types of a lever, the first one is the first class lever. Okay, first class lever or first order lever, you can say. Okay, so what is mean by first class lever? Okay, so this type of a question will be asked, explain the lever and explain the various types of levers. Okay, and advantages and leverage, so that question will be there. Okay, so in theory question for 4 marks, the question will be asked. Okay, so once the we will finish the first unit, we will discuss the papers of INSEMs of last years, last 2 years. Okay, because in INSEM there will be a weightage of 10 marks for each unit. Okay, as for INSEM you are having 30 marks, so each unit will have 10 marks weightage. Okay, first unit is of 10 marks, second unit is of 10 marks, third unit is of 10 marks. Okay, so likewise from each unit there will be a 10-mark question. Okay, in first question there will be a question for 4 mark and 6 mark, and or there will be directly question for 10 marks. Okay, in that 10 marks the question will be asked on quarter joint or knuckle joint for directly 10 marks. Okay, but in case of a 4 and 6 marks, the 4 marks will be question from maybe from types of a lever, what is lever, and 6 marks question will be of very short type of a problem from knuckle joint or a quarter joint. Okay, so please remember that. Okay, now we will see one by one. Now what is first class liver? Okay, what is the first class liver? Okay, here it is. Here is the definition for the first class liver. When the fulcrum is in between the load and the effort, okay, such kind of a liver are called as a first class liver. Okay, when your fulcrum is in between the load and the effort, such kind of a liver are called as a first class liver. Means your fulcrum will at the middle of the liver, okay, and your load at the left hand side and your effort at the right hand side. Such types of livers are called as a first class livers. Okay, so here is the diagram. Okay, you can also draw this diagram while in this lectures. Okay, so here is what the fulcrum is in between the load and the effort. Means your fulcrum is at the middle of the lever. Okay, okay, when your fulcrum is in between the load and the effort, in such type of a case you can call it as a first class lever. Okay, then there will be L1 and L2, effort arm and load arm will be there. Okay, so this such type of application will comes in your mind, then it is called as a first class lever. Okay, now here is the best example of the first class lever, that is plier. Okay, आपण पक्कड म्हणतो. Okay, here is what at the middle there is a fulcrum, there is a nut. Okay, means around that nut your movement will takes place. Okay, here is the input force you are applying and here is the output force, means whatever the thing that you have to pick up or that you have to tighten or loosen, you can do it over here. So plier is the best example for the first class lever. Okay, then yes, scissor. Scissor is one another example. At the center there is a fulcrum. Okay, in between fulcrum there will be the moment of that particular component above the fulcrum. Okay, here is you will apply the input force, that is effort. Okay, and here is the what load or what your or whatever actual cutting you will takes place. Okay, so these are the two best examples of the first class lever, that is scissor and the pliers. Okay, I think all of you got this, what is first class lever. Okay, so in this case the effort arm can be kept less than the load arm. Okay, now you can the question may come arise in your mind, why it is L2 is less, why here L1 is larger. Okay, it is not such case. You can keep L2 larger, L1 small, or you can keep L1 and L2 as same. Okay, it is depends upon application. Okay, so in this case the effort arm, okay, here L1 is kept, effort arm can be kept less than the load arm or equal to the load arm or more than the load arm. There is no any limitation for it. You can keep L1 greater, L2 greater, or L1 is equal to L2. Okay, okay, so accordingly, the mechanical advantage will vary in the following way. Once you will change the lengths, then your mechanical advantage is going to change. Why? Because mechanical advantage F upon P is depend upon totally L1 upon L2. That is totally depend upon effort arm and the load arm. Okay. So once you will change the lengths, so that mechanical advantage will vary accordingly. Okay. So how it is going to vary? Just see. When L1 is less than L2. Okay, when your L1 is less than L2, your mechanical advantage will be less than 1. Why it is less than 1? Because F upon P is equal to L1 upon L2. When your L1, that is numerator, is less than that denominator, then your advantage will be less than 1. Okay, when L1 is equal to L2, right, means L1 is equal to L2, means F upon P is equal to 1 by 1. So it is of F upon P, that is mechanical advantage will be what? 1. Okay, and when your L1 is greater than L2, okay, when your effort arm is greater than L2, that is load arm, then what will happen? Your mechanical advantage will be greater than 1. Okay, so I think all of you get this. Okay, how it comes. Okay, now the second one. Now the second class lever. Okay, now what is mean by second class lever? We will see. Okay, so here is the second class. Okay, in the second type of a lever, the load which is located between the fulcrum and the effort. Okay, in earlier first class lever the fulcrum was at the center. Okay, but in this case the load is at the center and your fulcrum is at the left hand side and effort is at the right hand side. So the load is located between the fulcrum and the effort. Okay, are you getting this? Okay, so in earlier case, the first class lever, your fulcrum was at the center. Okay, your fulcrum is in between the load and the effort. But in case of a second class lever, your load is located between the fulcrum and the effort. Okay, so what will happen? Here is the L1. L1 is the length. Means what? It is the length from the fulcrum to the effort. So here is L1 is greater than L2. Okay, are you getting this? Yes. So here is the best example for the second class lever, that is wheelbarrow. Okay, here is the fulcrum. Okay, here is the load. Output force means what load you are going to lift. Okay, which is in upward direction. Okay, and here is the input force you are applying. Okay, which is due to load, which will be in a downward direction, but you are acting opposite to the gravitational force. Okay, so this is the best example. Wheelbarrow is the best example for the second class lever. Okay, here is the fulcrum, here is the load and the effort. Okay, then the second example is a, yeah, it's what a bottle opener. Yes, it's a bottle opener. Okay, means what you will put that opening at the bottle head. Okay, here will be what you will fix the end point of that opener. So it is a fixed point, which is of a fulcrum, you can say. And here at the right hand side, you can apply the effort. Okay, means you will put means you will pick up that particular what tab or that cap of that particular bottle, okay, by means of a effort, and here is the load you are applying. So bottle opener is another example for the second class lever. Okay, okay, now the next is what, the effort arm. Okay, in this case the effort arm, okay, effort arm is what, L1 is always more than the load arm. Here you can see in the diagram as well, here L1 is greater than L2. Okay, and the mechanical advantage is a more than 1 because L1 is greater than L2, as here numerator is greater than denominator, that's why your mechanical advantage will be more than 1. Okay, so next is the third class lever, okay, or the third order lever. Okay, first order or first class, second order or second class, third order or third class lever, both are same. Okay, you can write third order or third class lever. Okay, so what is third class lever? In the third class type of a lever, the effort is located between the load and the fulcrum. Okay, now at the middle there will be the effort. Okay, that effort is located between the load and the fulcrum. Now you can see the diagram here. Now effort comes at the middle and that force comes to the right side. Okay, so the effort is in between the fulcrum and the load. Are you getting this? Okay, in case of a second class lever, the load at the center, but at the third class lever, the effort at the center. Okay, now the distance from the fulcrum to the load is nothing but L2, that is load arm. Earlier it was L1, now here L2. Okay, and the distance from the fulcrum to the effort is L1. Okay, now here your L2 is greater than L1. Okay, so what will happen, L1 is less, so L1 will be in numerator, L2 in denominator, and where L1 is less than L2, so what will happen, your mechanical advantage will be less than 1. Okay, here is the best example for the third class lever. Okay, here is what, fulcrum means this point. Okay, and here is effort means what, at that the what you can say, your at elbow is your fulcrum, elbow is your fixed point, right? Okay, those who are going to the gym, okay, the students, the generally boys. Okay, you can just consider this example as a third class lever. Your elbow is the fixed point. Here you can see diagram, here is your blue dot is the what, fulcrum, your elbow. Okay, and this hand, okay, hand will what, it will act as a to lift that particular load. Okay, this is what the load. Okay, dumbbells is what, load. Okay, which is acting in downward direction. Okay, and you will lift that load against the gravitation force. Okay, so this is what the fulcrum. Okay, fulcrum, that is elbow. Okay, and at the middle portion will act that your wrist will act like what, the effort which you are going to apply to lift that particular dumbbells. Okay, and that dumbbells is nothing but what, load. Okay, are you getting these examples? Yes, please. Are you getting this? What is third class lever? What is second class lever? Yes, please. Yes, yes, fine. Okay. Then one another example is of tongs. Okay, that tongs is nothing but आपण थोडक्यात म्हणतो आपण एखादं पकड वगैरे. Okay, here is what the end point. Okay, this is nothing but what fulcrum. Okay, the middle portion is what, at the middle portion we're applying the effort. Okay, and at the end portion we're plicking something, any particular component. Okay, so these tongs will be act like a third class lever. Okay, so this is the best example for the third class lever. So all of you, are you get this? What is first class lever, second class lever, third class lever? Okay, with examples, I have explained you things. Okay, I think you got this. Okay, up till this. Okay, shall we go ahead? Up till this, are you got this? Yes. Okay, so this is about the lever. Okay, what is mean by lever? What is mean by mechanical advantage? What is mean by leverage? What are the types of a lever? First class lever, second class lever, third class lever. Okay, then next is what, the bell crank lever. Okay, now what is bell crank lever? Okay, when the angle between the load arm and effort arm is 90 degree, then that lever is known as a bell crank lever. Are you getting this? When the angle between, आता earlier was total 180 degree was there. Okay, so but when the angle between the load arm, that is L1, and the effort arm is 90 degree, means L1 and L2 when will be the 90 degree, then particular that lever is known as a bell crank lever. Just I will show you the diagram here. Okay, so this is what F. Okay, here is what, okay, that P is the effort. Okay, this diagram is actually I have taken it from another book. So here is W, they have shown you. W is nothing but the load. Okay, and P is the effort, and here for fulcrum they have shown as a F. Okay, so here is the fulcrum. Okay, so that P means what, effort arm, means this is what, P means effort, that's why this is effort arm, and W means it is load, this is what, load arm. So 500 shows load arm, and that 150 shows effort arm. So the angle between load arm and effort arm is a 90 degree. That's why it is called as a bell crank lever. Okay, so this is the fourth type. Okay, fourth type of a lever, that is bell crank lever. Okay, now the next part, angular lever. So what is mean by angular lever? Okay, so just we will see, when the lever in which the load arm and effort arm are inclined at an angle other than 180 degree. Now here in bell crank lever it is of a 90 degree, but in case of an angular lever, when the load arm and effort arm are inclined at an angle other than 180 degree, other than 180 degree. Just I will show you the diagram. Here it is. Okay, here is what, theta is greater than 90 degree. So here is what, R is what, fulcrum. That R is nothing but the reaction at the fulcrum. Now P is the effort, W is the load. Okay, now this effort arm, that is L1 and L2, the angle between effort arm and load arm is greater than 90 or other than 180 degree. In such type of a cases it is called as a angular lever. When there is an angle between load arm and effort arm is a 90 degree, then you can call it as a bell crank lever. Okay, and here it is of a angular lever when the angle between load arm and effort arm is other than 180 degree. Okay, now the next part, one arm lever. Okay, now what is one arm lever? Okay, the lever which has only one arm, and that is nothing but the effort arm, that is called as a one arm lever. Now just can you please tell me the example for one arm lever just from your side? Okay, there is only one arm. Okay, and that arm is nothing but the effort arm. Now I'm expecting the examples from your side. Just that day to day life we are come across that one arm lever. Okay, just trace your just trace to your mind and just tell me the one arm lever. What is one arm lever? Just please, yes, from your side. I'm going to tell that application, but I'm expecting from your side. Just can you just think on it. One arm lever, it is only one arm. Okay, day to day life you are coming across it. Okay, and that particular arm is called as a effort arm. Just please, anyone from your side, just one example. Yes, yes, please. Yes, foot lever. Yes, yes, it is correct, foot lever. Anyone else? Yes, there are foot lever. Yes, it is, but particular application. Yes, anyone from Ankush Koth just is saying foot lever. Anyone from any other from Ankush Koth? Yes, anyone can tell me one example for one arm lever. Yes, wheelchair, bottle opener. Yes, yes, yes. Just I will tell you the examples. The handbrake in a car. Okay, those who are driving the four wheeler, there is a handbrake. Okay, which is of a one arm only, and this is directly a effort arm. Yes, brake pedal is also correct. Okay, lever in a lathe machine. Okay, that lever we use to change the speed for the particular levers for that particular lathe. That is lever. Okay, and the kick start in a two wheeler. Okay, that kick start we use for the two wheeler is the single arm one arm lever, and that is effort arm. Directly you are applying the effort which will gives you the result. Okay, so these are, yes, yes, fine, you also give the very good examples, it is very correct. So these are the various examples of a one arm lever, or a one arm lever example is in rickshaws. Okay, they use the one lever to start the rickshaw by hand. Okay, that is one type of a lever, that is effort arm. Okay, so this is about the what lever. Okay, so now the design of a lever part we will see it in the next lecture. Okay, so are you got this up till today's lectures? Okay, so what is mean by lever? Okay, what is mean by lever, what are the types of a lever, what is mechanical advantage, what is leverage, what is load arm, what is effort arm, what is bell crank lever, what is angular lever, what is one arm lever, what is first order lever, what is second third order lever. Okay, so all these points related to the levers are most important. It may be asked in an exam for 4 to 6 marks. Okay, so I think all of you get up till this. Okay, are you fine with this?